So 4-4, congruent triangles. Okay. 2 words, hopefully we know the definition for. What's the word congruent mean? Same size and shape. What's a triangle? 3-sided polygon. So we're talking about 2 3-sided polygons that have the same size and shape. They already have the same shape because they're both triangles. Okay. And now we're going to add in there that they have the same size. So geometric figures are congruent if they are the same size and shape. Something you've now heard a bunch of times. If they are congruent, then the corresponding angles and the corresponding sides are in the same position, the same position in the polygons with equal number of sides. So they have to have the same. You can't compare a triangle to a square. Okay, you can't say those are congruent because they have this different shape. But the 3 angles of one will match the 3 angles of the other, and the 3 sides of one will match the 3 sides of the other if they are congruent. Braylon?
What is geometric?
Geometric just is a shape, like a polygon. So something formed by a series of points. Okay. So in general, let's just say I had 2 shapes that are not triangles. Let's start there. So these 2 shapes can be congruent. They don't have to be facing the same way. Okay, so for some of you on your quiz yesterday, if there's a reflection or a rotation, those things were still congruent. The only time it's not congruent is when? The only time 2 shapes? When? A dilation. So if that was double in size or half the size. So some of you even wrote that the transformation was a translation, but it was not congruent, which is crazy. Okay? The only way it was not congruent is if there wasn't if there was a dilation. So these 2 shapes are the same. They're just rotated, okay? These would be congruent. And if they are congruent, then each of their corresponding sides would be congruent. So the AB would match FG. BC would match GH. DC would match EH, and AD could match EF. So you'd have 4 pairs of congruent sides because it's a 4-sided figure. And then the angles would also be congruent. So A could be congruent to F, B to G, C to H, D to E. Okay? So those would be the corresponding sides and corresponding angles. AB would correspond to FG. BC would correspond to GF or GH because it has 2 tick marks. DC would correspond to EH. AD would correspond to EF. So in this example, they're not saying triangles, they're saying any geometric figure. So I could compare 2 rectangles, 2 pentagons, 2 hexagons. If they were congruent, it means all the corresponding sides and all the corresponding angles would also be congruent. So these is what I just said. 2 polygons are congruent polygons if and only if their corresponding sides are congruent. Thus, triangles that are the same size and shape are congruent. So here's what a triangle or a pair of triangles that are congruent would look like. Notice that AB matches EF, BC matches ED, and AC matches FD. They don't have to be facing the same way. They could be turned. And then angle A matches angle F, angle B matches angle E, and angle C matches angle C. So if it asked me to write a statement of congruence, I would say that triangle ABC is congruent to. Now the order of the letters now matters. Whichever angle matched where A is what I got to go first. So which letter or vertex in the second triangle is where A is on the first one? F, not necessarily is where it is, but has a single tick mark. And then B matches E, and C matches D. This is a statement of congruence or congruence statement. And the order of the letters matters. I can't say A, B, C is congruent to D, E, F because the A and the D are not corresponding. And this corresponding is different from your corresponding angles with your parallel lines. All right, so this is just a little bit of a graphic. So if it asked you, if it gave you the ones on the left, it gave you the shapes, it said that they were congruent, and then it asked you to identify the corresponding angles and the corresponding sides. You give these in pairs. So based on the triangles that are there, so this one is based on these two triangles, okay? Triangle ABC and DEF. Notice that they're turned, okay? But the angle with one arc matches the angle with one arc. So A matches D, 2 arcs matches 2 arcs, so angle B matches E, and 3 to 3 C matches F. So these would be my corresponding angles. A is congruent to D, B is congruent to E, and C is congruent to F. And then my sides, again, I identify the same way. One has 1 tick mark. So AB matches E, D, or DE. The order of those individual letters doesn't matter, but the AB has to go with DE. Then BC is 2 tick marks, which means it matches EF, which has 2 tick marks. And AC has 3 tick marks, which matches DF, which has 3 tick marks.
What do the tick marks represent?
Like, it's just the pairing of them. So one with 1 tick mark matches any other side length that has 1 tick mark. One with 2 is the same length as anything else that has 2 tick marks. So so if I told you that this was 3, whoops, what did I say? Let's say I told you the length of this was 3, this was 5, and this was 4. Then I would know on the other triangle, this is 3, this is 5, and this is 4 because of the pairing of the tick marks.
And then what would the lines on the inside mean?
They're angles. So angle A matches angle D. So if I told you angle A was 30 degrees, let's say, you could tell me angle D was 30 degrees.
Okay.
And then the same thing, 2 matches 2 and 3 matches 3. And then the one on the bottom is just based on a quadrilateral now, okay? Those are actually rectangles. Okay, polygon QRS is congruent to polygon WXYZ. If that's the case, then the order of the letters matters. P goes with W, Q goes with X, R goes with Y, and S goes with Z. And this time it's a little bit harder to see that from your diagram, but what you can use is your congruent statement. So the order of the letters here would tell me that P goes with W because they're both the first in that name. Q goes with X because they're both the second in that name. R goes with Y, they're both the third in that name. And then S goes with Z because they're both in the fourth of the name. And then the sides just go in twos. PQ would match WX, QR would match XY, RS would match YZ, and then the first and the last, PS, would match YZ, or WZ. So you can either use the picture or a congruent statement. And sometimes you won't get a picture. You'll only get the congruent statement. So you got to make sure you know how to read both of them. All right, so naming the polygons. The 2 vertices are the endpoints of the side are called consecutive vertices, one after the other. So if I'm going around my vertices like clockwise or counterclockwise, the ones that I hit one after the other are called consecutive vertices. To name the polygon, you have to write the vertices in consecutive order. So something that is called PQRS can be named as, not SAS, as QRSP or SRQP, but it can't be named as PRQS. I'll give you a visual. It's a little bit easier. Okay, so let's say it is P, Q, R, S. What this is saying is I can go in any order as long as it goes consecutive, which means I can go start with the P, come around to the Q, then to the R, then to the S. I could name it that way. Or if I start with the Q, I could start with the Q, then go to the R, then go to the S, then go to the P. I could start with the R, and go to the R, from the R to the S to the P to the Q. Okay? Or, I mean, you can name them a lot of different ways, but let's say I started with the S. I could also go S to the R to the Q to the P, that direction. As long as I go consecutive, either clockwise or counterclockwise. I can't bounce around. I can't say, okay, S to Q to P to R. That's not consecutive. So you're either going around the polygon clockwise or counterclockwise. I just can't skip around. Does that make sense? So in a congruent statement, the order of the vertices indicates the corresponding parts, which is what we just talked about. If I wrote that PQRS was congruent to MNOP, then what angle corresponds to angle Q? What would be congruent to angle Q? Angle N. What would be congruent to angle S? Angle P. What would be congruent to angle P? Oh, I did P twice. Sorry, that's a bad example. MNO. Let's call it T. Okay. What would be congruent to P? M, right? So P would go with M, Q would go with N, R would go with O, and S would go with T. Does that make sense? Yes? What about side lengths? What if I said side QR? What side length matches side QR? NO. Does that make sense? Yes. How about if I said PS? M. T. Okay? So the order of the letters is important. Alright, so given triangle PQR is congruent to triangle STW, identify all pairs of corresponding congruent parts. Which means give me all the pairs of congruent angles and all the pairs of congruent sides. If you want a visual, draw it out. But you don't need it if you go off the letters. So give me a list of all the corresponding angles and all the corresponding side. Three pairs of corresponding angles. P and S, so angle P is congruent to angle S. What's another one?
T and Q.
T and Q, so Q is congruent to T or T is congruent to 2, either order. And the last one? R and W. Raise your hand if you got all three right. Easy stuff, right? Just matches the letters. Okay, how about the corresponding sides? If I told you PQ, what does PQ match? Can I call it QP?
Yes.
Yeah, it doesn't matter. How about TS? Doesn't matter. Okay, as long as those two match those two, the order does not matter. Yep.
On the quiz, if we have a quiz in this, do we have to write the first sides line?
Like the segment? I'm not going to take points off. If you don't have a line there, it implies segment. So just if you meant for it to be array, then it's wrong. Or you meant for it to be a line, then it's wrong.
No, like if it asks for the sides.
Right.
Corresponding sides?
No.
No?
So then, let's say QR. What would be corresponding to QR? TW. And the last one, PR, would be congruent to? SW. Good. Questions on either of those? Corresponding angles, corresponding sides. RP? Sure. So RP could equal SW or RP could equal WS. Though the letters themselves can be interchanged because we're talking about a segment and the order doesn't matter. God bless you. All right, so we'll do this one together. Polygon LMNP would be congruent to EFGH. How many sides are in these polygons?
4.
Good. And how many angles?
4.
So I'm going to have 4 pairs of each. So the sides, angle L would be congruent to angle E. Angle M would be congruent to angle F. Angle N would be congruent to angle G. And angle P would be congruent to angle H. Everybody good on that? So I could have written the P and H first. The order actually doesn't matter. I just tend to go off of the order that's there. and then the sides. So LM would be congruent to what side? EF. MN would be congruent to FG or GF. NP is GH or HG. And LP is think about the location of the letters. L is where on those four, right? First and last. EH. Question? Huh? No, there's a little, like, the concept, yeah, but there's a little bit more different
So
practice.
you need to do all of them if they ask.
Yep, so it'll say all pairs of corresponding congruent parts. If it was 5 sides, there'd be 5. If it was 10 sides, which would just not be fun, there would be 10. Okay. So now again, like usual, they throw back in the algebra part of this, right? So this is where you get to reminisce about the good old days of algebra. Find, or given that triangle ABC is congruent to triangle DBC, find the measure, and it's got 3 letters, folks. DBC. Where's the vertex in that? B, okay? But I still need the other letters because what's true about B? Is there only one angle there? Where B is? B, that vertex is technically shared by 2 angles. 3 if you include the big one. So that's why you have 3 letters, okay? So the measure of angle D, BC goes in that order. D, then B, then C. So I'm talking about this angle in here. All right, so let's think about what we've got going on inside this triangle. A is congruent to what? D, which means that this one is 49.3. Because the order of the letters here, right? A would match D. B matches B. That means that this one is congruent to this one. And then C matches C, which means this one is congruent to this one. So now how, with that information, can I get to that third angle? Okay, that's one way to do it. So because this is 90, right? And I know that this is 49.3 and this is a triangle. I can say that 90 plus 49.3 plus angle B, or angle, let's give it 3 letters because I need 3 letters, CBD, equals 180 degrees. So that angle CBD is my unknown, which means I can add these 2. I'd get 139.3 plus the angle equals 180, and then just subtract 139.3 from 180. So 0.0. This would be 704. So I'd get angle CBD equals 40.7. Can anybody see a different way to do it? Because there's more than one way. What if it had first asked you to find x? How would I do that? Meldrick?
It would be 2x minus 15 equals 49.3.
Nope, not 49.3, right? This is the angle in here that's marked as 2x plus 16 minus 16. What angle is that equal to? The 90 degrees. So you could have either gone off your corresponding angles in your order of letters, or those 2 are linear pair. If one of the 2 angles that form a linear pair is 90, the other one's got to be 2. So I could have also said that this equals 90, and then I would have gotten 2x equals 106, and x equals 53. That would have given me the x value. This would have been, plug it back in, this would have been 90, okay? And I could have used these 2 to find the missing angle. So I would only do that if you were missing, if it asked you for x. If not, then it's way faster to just do it the first way that we did it, because either way you'd have to plug it back in. Questions on that one?
Why did you put?
All right, this one says, given triangle ABC is congruent to triangle DBC, find the value of x and then find angle F. So now I've got a mixture of angles and sides, okay? The value of x means I have to use this AB in some way. So what side in the second triangle would match AB from the first triangle?
DB.
DB, and it's not necessarily all, oh, that should be an E. I didn't change it there. Sorry, make sure you make that correction. That should be DEF. So the AB would match the DE, which means that this side would match this side, or 2x minus 2 would equal 6. 2x would equal 8, and x would equal 4. Now I've got the x. And then the second part of this asks for the measure of angle F. So how do I find that? Because F has nothing to do with the side length, right? 6 is not going to help you. 10 is not going to help you. 2x minus 2 is not going to help you. What angle from ABC would match angle F?
Wait, why did you put 2x minus 2?
What would be congruent to angle B from the first triangle in the second triangle? Angle E. So this one matches this one, which means that this would be 53, or I could use it in the other triangle, okay? So if I'm looking for angle F, how could I find it?
2x minus 2 is equal 6.
Nope, the 2x is a side length, so it has no relationship to my angle. I can't use that 2x.
Watch out for 6. Like,
But I already solved for x. What if I'm looking for angle F now, right? How could I find angle F? Good. So both of you are right. I could either use all three angles and say 180 equals 90 plus 53 plus angle F, and then subtract the 90 and the 53. So 180 would equal 143 plus angle F, subtract the 143, and I get 37. That's one way to do it. The other way is the theorem that we learned in section 3 said that the acute angles of a right triangle have to add up to 90 degrees because they're complementary. So E and F have to add up to 90, which means I can do 90 minus 53, and I get 37. So either way, angle F would be 37 degrees. Questions on either parts of that? The moment you've all been waiting for. Okay. All right, so let's see how much of this we can work through together. So it says, given PR and QT bisect each other, angle PQS is congruent to RTS, and PQ is congruent to RT. Prove that triangle QPS is congruent to triangle TRS. So kind of work backwards. Think about the end. The end goal is to get that those triangles are equal to each other, right? So in order to state that two triangles are equal to each other, what do I have to know about those triangles?
their lengths.
All three pairs of sides or lengths have to be the same, and we've been talking about two different measurements on these triangles today. And all three pairs of angles, good. So eventually, if I didn't have the left side statements, you would die, probably. But let's just say you didn't, and you actually had to work through this all by yourself, okay? Your goal would be to prove that each pair of corresponding angles is congruent and each pair of corresponding sides is congruent. If you had that, then you know the triangles are congruent, which is the end goal. So let's see what information we do have. Let's not freak out just because it says the word proof. This actually might not be so bad, right? Label your diagram with the information that you have. So the first thing says that PR and QT bisect each other. That's your given statement, right? Where's that in my statements? Third one over, or third one down. That's given. The next thing says PQS is congruent to RTS. Try to mark that on your diagram, since we know we struggle with the three letters. Mark that on your diagram. Mark that PQS is congruent to RTS. So find those angles and draw a little arc on them. PQS and RTS. Don't even look at the statements. Just look at your diagram and label that PQS would be congruent to RTS. Did you mark there?
Congruent to what?
To each other. PQS, which is this angle here, is congruent to RTS, which is this angle here. How many of you at least marked it right? Because obviously that was something that stumped a lot of you yesterday. Okay, good. All right. So that's also part of my given, and which number step is that? Angle PQS is congruent to RTS. Where's that? Step 2. And then the last one that's given is that QP is congruent to RT. So again, if I were to mark my diagram, QP is congruent to RT, it would look like that. And what step is that in my list? Given, and it's first, right? So the first 3 were given. All right, number 4 says QS equals TS and PS equals RS. Where did that come from? How do you know that? We're talking about segment lengths, first of all. What part of that given is talking about segment lengths that you could take to the next step? Number 1 states what it is, right? PQ is equal to RT. Then 2 is about angles. 3 says PR and QT bisect each other. What does it mean if they bisect each other? What about where they intersect is special, right? It cuts them into 2 congruent parts. So if I were to just go off of what they gave me, the fact that PR and QT bisect each other means that it cuts these into 2 congruent parts, which is what number 4 says, right? QS is equal to TS, PS is equal to RS. That's the definition of a bisector. Okay, which says that 2 segments that bisect each other, or something that bisects the others, would cut them into 2 equal parts. Number 5 says QSP is congruent to TSR. So go to your diagram. QSP is equal to TSR. Which is this angle and this angle. How do I know they're congruent? They're vertical angles, okay? So the vertical angles by definition just as vertical angles. The vertical angles theorem is what tells us that those are congruent. Six says QSP, so let me erase some of this so that we can see it a little better. QSP, which is this angle here, is congruent to TRS, which is this angle here. How do we know that? So we had marked these 2 were congruent, and we had marked Q. Those 2 were congruent.
Does the alternate, interior stuff go with this or not?
If the lines were parallel, but the lines aren't parallel.
Corresponding.
Actually, this is wrong. Sorry, this should be Q. S. So let's do this color coded. We started with these 2, right? We started with this one and this one, and then we did this one and this one. And this statement is saying this would be equal to this. How do I know that? Nope, that would you'd have to say something is parallel in order to know that.
Corresponding?
You'd have to know that the lines are parallel. Nope. Third angles theorem. Good job. Okay, we just got off that section, right? 4.3 said that if 2 pairs of angles in a triangle match 2 pairs of angles in a second triangle, then the third one would be equal as well. That is third angles theorem.
Wait, so is it, if you said you gave them a top, that they're parallel? Here.
Then you could use alternate interior, alternate exterior, same side interior, and corresponding angles.
Oh, if it said PR and PT are parallel?
If it said like QR and PT are parallel, then you could have used those. Or it said QP and RT are parallel, then you could have used the other ones.
Oh.
Yep. All right, so then the last step, QPS is congruent to TRS. What did we say makes two triangles congruent to each other? How do we know that they're congruent?
Yeah.
Nope. All triangles add up to 180, right?
Same angle.
Part of it. What two things have to be true about two?
Corresponding angles and sides.
Good. All the corresponding sides and all the corresponding angles have to be congruent. Okay? So for now, that's the only way we know that two triangles are congruent. The good news is tomorrow and Friday, we're going to learn some shortcuts, okay? For right now, you'd have to go through proving that all three pairs of sides are congruent and all three pairs of angles are congruent. But again, tomorrow we'll learn some shortcuts. Questions overall on 4-4? All right, so the only concept is really that the angles all match and the sides all match. But what you have to take from that is that the order of the letters is important, and that if there's algebra or there's some expressions on there, that you match them up also equally.